Hey there everyone, welcome to Software's classes. Here, let us try to study this question, okay? So this is again as we are solving our Indian Economic Service Series questions. So this is from IS 2022 question paper, and here we have to show the relationship between the relative prices of output and relative factor rewards in the light of Stolper-Samuelson theorem. So relative price of output here means P1 by P2 if we assume that the price of the commodities are P1 and P2, and the relative factor rewards are the wage rate and rental rate, that is the wage for labor and rent for capital. So now first let us try to understand what is our theorem, Stolper-Samuelson theorem, okay? So our Stolper-Samuelson theorem postulates that. What does it postulate? Any increase in the relative price of commodity will lead to the increase in factor payment of a factor used intensively in that commodity. So what is the meaning here? So it simply means that suppose I have two commodities X1 and X2, and if the price of X1 and X2 is P1 and P2, and these two commodities are made using two factors of production, labor and capital. Now suppose X1 is labor intensive and X2 is capital intensive. So if P1 by P2, that is the price ratio, price relative of X1 increases, so that means P1 by P2 increases means P1 has increased. So P1 is the price of X1 commodity and X1 is made using labor intensively, that is X1 is labor intensive product. That means the wage should increase, as a result wage by rental rate should increase, okay? So what is the meaning here? The meaning here is, suppose there are two commodities X1 and X2. Their prices are P1 and P2, okay? The factors used are labor and capital. Returns to labor is wage rate and returns to capital is rental rate. So these are the information that we have. Now, according to the Stolper-Samuelson theorem, okay, one more thing, say L1 is labor intensive good, okay, and X2 is automatically capital intensive. Now, according to this theorem, if P1 by P2, that is relative price of a product increases, that is relative price increases for X1, then obviously X1 is what? Labor intensive, and the return to this is W, which will increase. Why? As a result of increase in this, so the factor used intensively, the return will increase. So that is W by R will increase. So this is our Stolper-Samuelson theorem, which means that if the relative price of a product increases, then that particular product uses whichever factor intensively, the return to that factor will increase. That means here, since X1 is a labor intensive good and P1 has increased, so obviously the return to X1, the factor used here is labor, so the wage rate will increase, as a rate wage rental ratio will increase. This is our Stolper-Samuelson theorem. Now let us try to establish the relationship using mathematical derivation. Okay, so for this, the first step is, let us assume two set of equation for A country, 2 commodity, and 2 factors of production framework, right? So that is AL1 into W plus AK1 into R is equals to P1. Let's say this is equation 1. And next one is AL2 into W plus AK2 into R is equals to P2, and this is equation 2. So here Aij represents amount of ith factor. What is ith factor? I is equals to L comma K. Okay, amount of ith factor used to produce 1 unit of xj commodity. J is equals to 1 comma 2. That means we are talking about x1 and x2 commodity, right? Now again, this is fixed. These coefficients are fixed. So let us take total differentiation of equation 1 and 2 we get. That's all. So if we take total differentiation of equation 1, what do we have? We have, this is fixed, so AL1 into dW plus AK1 into dr is equals to dP1. Okay, now let's try to moderate and simplify this. Okay, so what are we going to do? Next step is, let us divide with W, multiply with W, and divide with again P1. Okay, plus again AK1 divided by R into R by P1 is equals to dP1 by P1. Okay, so we have P1, that means we have divided P1 on both sides of the equation, and we have included W by W and R by R in each term. Now why did we do this? Okay, so for that, see, dW by W, this is the proportionate change in wage rate, and dr by R is the proportionate change in R, and dP1 by P1 is the proportionate change in price. So we can write down the next line as AL1 into W by P1 into proportionate change is W, that is W hat, plus AK1 into R by P1 into R hat, that is proportionate change in rent, is equals to P1 hat, that is the proportionate change in price of commodity 1. Now let us denote this as the share of labor in the price of the first commodity, share of rent in the price of the first commodity, with theta. Let's say this is theta L into W hat plus theta K into R hat is equals to P1 hat, and we say this is our equation 3. So similarly, if we differentiate equation 2, so similarly from equation 2 we get, since it is 1, so we will mention 1, theta L1 and theta K1. And for second commodity, so we will get theta L2 into W hat plus theta K2 into R hat plus P2 hat. This is 4. Now theta L1 plus theta K1 is equals to 1. Similarly, theta L2 plus theta K2 is equals to 1. This is the total share of labor and capital. So now from equation 3 and 4, okay, from equation 3 and 4, from this equation 3 and 4, it is very clear that P1 and P2 should lie between the wage rate as well as the rental rate of the factors. Then only it will satisfy the share, because P1 is in the share of this one and this one together, which is the total share 1. So obviously it cannot exceed W. That is why. So from 3 and 4 we can write down, from 3 and 4, it is clear that W hat, it is clear that P1 hat and P2 hat will lie between W and R. Let's say this is 5. So we have deduced few equations here. Now what we are going to find out is, using equation 3 and 4, we are going to calculate our theta determinant. Okay, that is, we are going to include all the shares of labor and capital and calculate the determinant. So theta is equals to theta L1, theta K1, theta L2, theta K2. Now let's solve this determinant. That is theta L1 into theta K2 minus theta K1 into theta L2. Now this is equals to theta L1. In place of theta K2, I can write down 1 minus theta L2. Similarly, in place of K1, I can write down 1 minus theta L1 into theta L2. So we get theta L1 minus theta L1, theta L2 minus theta L2 plus theta L1, theta L2. So this and this term gets cancelled, and we have theta is equals to theta L1 minus theta L2. By similarly, instead of changing theta K2, if we write down L1 with respect to K2, then this whole equation, this whole value of determinant, we will get in terms of capital. So this same equation can be written as theta K2 minus theta L1. If you want, you can check it by substituting theta L1 with 1 minus theta K1 and theta L2 with 1 minus theta K2, and then derive all the form that you will get is theta K2 minus theta K1. So both of these equation is possible. Let us name this as equation 6 and equation 7. Now let us assume that commodity 1 is labor intensive, right? X1 is labor intensive. Then what can we write? We can write AL1 by AK1, right? That means use of labor to produce the first commodity is greater, where to this is greater than AL2 by AK2. This means for the commodity 1, labor is used more respect to the capital. So obviously in 2, labor is used less intensively compared to capital. So the ratio, this ratio for the first commodity is greater than the second commodity, right? Now next line, AL1 by AL2 greater than AK1 by AK2. Okay. Now let us incorporate these variables. That is, let's write down AL1 W by P1 whole divided by AL2 W by P2. So W and P1 by P2 is here. So similarly, we will incorporate here AK1 into R by P1. See, P1 will get cancelled, W will get cancelled, and by same logic, AK2 into R by P2. So basically, we have balanced both sides by dividing P1 by P2 as well as dividing W on one side and R on the other side, such that this equilibrium is maintained. The balance on the left hand side and the right hand side is maintained. We have just added the variables that we need. Now why do we need it? Because we have to write it in forms of the shear. Because it is very clear that AL1 into W by P1, this is what? This is theta L1, as we have done in equation number 3 above, divided by this is theta L2. This is greater than theta K1. This is the capital shear in commodity 1 and commodity 2. Now we can solve it in this way. Theta L1 into theta K2 is greater than theta L2 into theta K1, which can be written as theta L1 into theta K2 minus theta L2 into theta K1 is greater than 0. Now try to recall this equation. If we go up, 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 this is nothing but our determinant value, theta L1, theta K2 minus theta K1, theta L2. So let us write down that the determinant is greater than 0. So this implies that the value of determinant is greater than 0. Now, since theta is a fraction, so obviously 1 by theta will be, since theta is a fraction, so we can write down theta is obviously greater than 0 but less than 1 because this is a fraction. Therefore, 1 by theta is greater than 1. Okay. This is another important result that we will need in order to prove the Stolper-Samuelson theorem. So this one we have got. Now what is the next thing that we are going to do? The next thing that we will be checking here is basically we will subtract the equation 3 and 4. Let's check if it is 3 and 4 or not. That is both the differentiated equation. Yes, 3 and 4. So we will subtract these equation 3. This is our equation 3. And this is our equation 4. We will subtract these two. So what do we get? We get theta L1 minus theta L2 into W hat minus theta K2 minus theta K1 into R hat is equals to P1 hat minus P2 hat. This is the result that we have got. Now, we know that theta L1 minus theta L2 is equals to theta K2 minus theta K1. We have got this result from the determinant that we have solved. We can also again solve it here. We can show because theta K2 is what? Theta K2 is 1 minus theta L2 and theta K1 is what? 1 minus theta L1. So after solving, what we will get? We will get theta L1 minus theta L2 into W hat minus theta L1 minus theta L2 into R hat is equals to P1 hat minus P2 hat. This is what we will get. So now let us take this as common. So we get theta L1 minus theta L2 as common and we have W hat minus R hat remaining, which is equals to P1 hat minus P2 hat. Now let us put the value of determinant here. That is, we get W hat minus R hat is equals to 1 by determinant of theta into P1 hat minus P2 hat. So let's say this is equation number 7. Now using this, we are going to prove the Stolper-Samuelson theorem. How? See. So we suppose that according to the Stolper-Samuelson theorem that we have assumed suppose price of first commodity is greater than the price of second commodity. This change in the price of first commodity is more than that of the second commodity, right? So this is clear that P1 hat minus P2 hat is greater than 0. Again, we have just now saw that 1 by theta 1 is greater than 1. So this is very clear that W hat minus R hat is greater than P1 hat minus P2 hat. Why? Because this is equal when this term is multiplied. So W hat minus R hat is equals to this price difference into something that is greater than 1 is multiplied. So obviously this is greater compared to just P1 hat minus P2 hat. So that is what we have written, that W hat minus R hat is greater than P1 hat minus P2 hat. And now we know that P1 hat minus P2 hat is greater than 0. So this implies W hat minus R hat greater than 0 implies W hat is greater than R hat. When? This is possible when P1 hat is greater than P2 hat. So this two line is actually our Stolper-Samuelson theorem's postulate, right? That is, if the price of this commodity, if the price of X1 commodity increases more than the price of second commodity, then the factor used intensively to produce X1, that is labor, its return will increase more. That is, W will increase more than rent, right? So here we have proved our Stolper-Samuelson theorem.